In this video, we're going to look at what are called identity elements for binary operations. So we're going to let triangle be a binary operation on set S. And if E belongs to S and E has the property that E triangle S is equal to S triangle E, and both of these things are equal to S, for all S's living inside set S, then we're going to call E. So we call E is a two-sided identity element for triangle. And you know about identity elements. Two-sided identity elements are often called just identity elements. So it is common to call a two-sided identity just an identity element. And so I first of all want to look at some examples of two-sided identity elements. So as an example, if we look at R under plus, we know that 0 is a two-sided identity element. And we know this because 0 plus anything is equal to A plus 0, and both of those are going to be equal to A. Likewise, if I look at R under times, I know that R under times has a two-sided identity element, namely 1. So the number 1 is a two-sided identity element. And the reason why, again, is that 1 times A is equal to A times 1, and that's equal to A. And both of these statements are true for all real numbers. And that quantifier is important. So I kind of want to look at the symbolic way of writing a identity element. So we say triangle has a two-sided identity element, and let me clean up my writing there. Inside the set S. So we say that triangle has a two-sided identity element inside of set S. If and only if, because this is a definition, there exists somebody that is usually called E living inside S, such that for every little s living inside S, we have E triangle S is equal to S triangle E, and both of these things are going to be equal to S. Now, it is extremely important to understand that the quantifiers, this is a doubly quantified statement, and the order of the quantifiers is critically important. And let me make that. So it's really important to understand that. And to prove that something is a two-sided identity, you have to look at both E triangle S and S triangle E, and you have to prove that both of those are equal to the S element. There is another variation on identity element, which is what I want to look at next. So the next thing that I want to look at are what are called right identity elements. And again, we're going to let triangle be a binary operation on set S. If we can find an element that I'm going to call E sub r, and I'm just going to call it ER. If we can find an ER inside set S with the property that S triangle ER is equal to S for all little s's inside set S, then we're going to call ER a right identity element for our triangle operation. And it's referred to as a right identity element because you'll notice that the right identity is on the right side of the operation. A left identity element would be on the left side of the triangle. So that's what a right identity element is. It is important to understand a couple of notes about right identity elements. So some notes. If E is a two-sided identity element, so if E is a two-sided identity element for triangle, then clearly E is also a right identity for our operation triangle. And that's because if I know that E triangle S is equal to S triangle E, and both of these things are equal to S, this part of the definition of a two-sided identity element says that E is two-sided identity has to imply that E is a right identity element. But it's also important to understand that right identities might not be two-sided. So let's look at that as well. So note, a right identity element might not be a two-sided identity element. And I want to show you that by looking at a special example. Let's look at the real numbers under subtraction. Since a minus 0 is equal to a for all a's that are pulled from the real numbers, we see that 0 is a right identity for subtraction. But if I turn this around and look at 0 minus a, that's equal to minus a, which in general is not equal to a. And as a consequence, 0 is not a two-sided identity for subtraction. So subtraction. So it's important to realize that some operations will only have a right identity instead of a two-sided identity. Division would be another one of these kinds of operations.